A video I wanted to do yesterday when I was able to breathe a little bit better. Now I can't, but now out of spite due to my medical condition, just an injured lungs and sinuses right now, I'm going to try to get through this. This video will be about firearms and specifically shotguns and safety and real world results, whether you like it or not. And this has to do with hunting / self-defense ranges for firing buckshot and slugs. Now, the reason for this is about the safety issue. You can usually hit something at a much longer distance than you could actually try to hit something. You can accidentally hit something you didn't intend to hit at a much greater distance than you can deliberately hit with every cartridge. Everything, literally all the way down to the weakest cartridge ever made, has a much longer range of inaccurately hitting something to injure, or maybe worse, than deliberately hitting a target. Now, shotguns are a weird mix because it's presumed that the max distance and the max effective distance are almost the same. Now we're going to look up real-world tests. Primarily, this will be based on a 2014 project done by a YouTube channel and hobbyist called Brass Fetcher. The maximum self-defense range, and it also involves hunting because they're almost linked to each other, for double-aught buck, number 1 buck, and number 4 buck. If you're not aware of it, number 4 buckshot is about the small size that anyone is willing to call buckshot. It's the minimum size you could use at some hypothetical range to hunt a deer. And slugs obviously can be used for the same reason. This is based on the pseudo-standard in the industry of finding cartridges that are approximately near an ounce or an ounce and an eighth of material being fired, but it doesn't have to be. This is mostly what was on the shelf at Walmart. And 1,250 feet per second for the average. Because of the speed, they all tend to have very comparable ranges, or at least hypothetical. And this is done through a 30-inch barrel because that's the standard SAAMI uses. That's 2.5 feet approximately. And the testing was done with a cylinder bore barrel and other barrel types, depending on which part we're talking about here. But in the case of the SAAMI barrel, it's a 73 caliber or 72.5 caliber barrel, depending on where you measure it. But it's considered industry standard barrel for shotgun testing. That's what they base the numbers on the side of the box for in the United States. 30-inch barrel, etc. And we're going to assume 1,250 feet per second, just because for sake of argument, that's common. Testing plain lead, high antimony lead or other metals like tin, and copper-plated lead. The idea here is that each of these stages makes it more likely that the pellets come out round, which means they tend to fly straighter, stay together better, and they tend to hit harder because they're not wasting energy due to wind drag or deviation eating up the energy. It should be pointed out that the larger the shot, the more mass it has. It's heavier. But the surface area that causes the drag to slow it down doesn't change as rapidly as the heaviness of the pellet. It's the square cube law. You might have looked it up. Basically, it means the larger the shot coming out of the barrel, the longer its range will be because it isn't equaling out with the wind drag as much as you might think. And we're also referring to deformed pellets because of whether or not they're hardened or plated versus non-deformed. And also comparing pattern controlled methods and wadding systems and buffering and unbuffered materials and etc. So I'm going to read the results. By type of cartridge, 24 caliber or number 4 buckshot, using unplated lead or plated, but using a pattern-controlled system, basically a flight control wad. The kind of thing that makes it where it spreads the least possible, even out of a plain gun with nothing special. Effective range was only around 30 feet. It needs to be heavily buffered or in a wad or both. Buffer is just powdered material mixed in so that as the shot is fired, the pellets won't crunch into each other under force. They're held apart from each other by some filler material. It can be almost anything. That's the shortest range, and that was only out of a specific set of cartridges. They needed to not be deformed as they came out. Deforming it made it to where the pellets were useless at any range that would be considered of any value. But that means number 4, good ammo would be useful within that range to hunt or to take out pests or to dispatch an animal that's extremely sick or is dying from rabies or whatever, and also an attacker. 30 caliber or number 1 buck. Buffered, unplated, deformable, but still in a buffer material. Shot, max range. This, again, was the usable cartridge. The ones that weren't really useful were thrown out as far as the subject matter. 30 yards. Number 1 buck with pattern control and copper plating to reduce the deformation. 50 yards. That's it. That's based on whether or not it would do any damage on impact. Not whether or not you got all the shot in the right spot. That's a lot of variability due to the gun that it's fired from. How you operate it. Whether or not you actually know what you're doing aiming it. But that's 150 feet. Now, double-aught buck. That's 33 caliber shot. The liability range I'm going to refer to because it comes up with double-aught buck. The others are almost the same range at 50 or 60 yards as the liability range, meaning a pellet can still hit and be injurious or lethal. Max range is around that, but not really much further than like 50 yards. So all of these were within a 50-yard range, which makes them a lot better of an idea. Again, if you need to go more than 50 yards and it's a self-defense situation in a courtroom, you're going to have a lot of trouble explaining why 150 feet away someone was an imminent threat and you couldn't run or hide or avoid. It depends on the situation. But at 90 yards, double-aught buck, liability range, means it'll go through a 2x6. It's lethal. But whether or not you can aim it accurately or get all the shot where you want it to, that's dependent. Buffered, unplated, but deformable shot, max range was 40 yards. It's 50 yards if you do the good stuff. Copper plating, pattern control wad, all the bells and whistles that cost 20 cents more per shot. And that's where you get these magic 40-yard and 50-yard quotes. That's the range they found with the guns they were using and the shot they bought off the shelf, unless you load it yourself some weird way. That was your maximum range that would do you any good for both hunting or self-defense. And if you're not aware of it, at 40 yards or so is where you're supposed to pattern shot for your stated pattern density for shotguns, the chokes, that sort of thing. If you were to elevate the gun and point it up in the air, we're now talking about double-aught buck. What's the maximum range the pellets will land? That doesn't mean they're going to do anything. That's the maximum range where you might crack a windshield. You might actually maybe hurt somebody, 1,000 yards. Again, I've said it before, I'll say it again, even a 22 short, considered one of the weakest cartridges on the planet, can still either hurt or maybe really hurt, maybe kill somebody at almost a mile away. So, yeah. Know what you're aiming at. Know what's behind it. Make sure that it will hit where you aim. If you can't predict whether or not the thing is actually going to hit where you want it to, you should not take the shot. Optimum muzzle elevation again with a slug. This is literally a 72 or 73 caliber bullet basically coming out of the gun. 1,200 yards. Laws banning hunting within a quarter mile of an occupied dwelling means that that's only a range of 440 yards that they're restricting you to. It's not 50 yards, like the effective range, it's not, you know, more than a quarter mile. I mean, it's, you know, that's bordering on almost a full mile there. That's a lot. 1,000 yards is a bit extreme. So half a mile should be the range, but many parts of the country restrict you from, you know, being any closer than a quarter mile. I guess they figured that's good enough. A 12 gauge slug fired at and hitting at 100 yards or 300 feet will drop in velocity almost 400 feet per second and has a 3-inch range of high and low spots between those 2 points where it can come up and come down. You could zero it for 100 yards and it'll go up maximum of 3 inches high. That means that if you were to zero it that way with, depending on the gun, depending on the slug, you would hit within a 3-inch of whatever you're aiming at, up and down. The grouping is a spread of 9 inches. That's the entropy, or pattern entropy, or the patterning, or the grouping in this case. 12 gauge double-aught buck. We're not even considering the others right here. 225 feet, or 75 yards. We get a drop of 360 feet per second. It's a little less of a drop. And you get a drop, physical drop in height of 3.4 inches from whatever your optimum line is. It goes up and down, 3-inch, 3.5 inch, maybe 4-inch wide swath of an arc through space. Fairly similar, but it's 225 feet instead of 300. But what would the pattern be? Because we don't have a group here, it's a bunch of shot going down range. Shot patterns are assumed when you hear about it. You hear that you're supposed to hit a 30-inch circle at 40 yards and count how many pellets out of the number that's supposed to be in the cartridge. And you'll see a quote of a 1-inch spread every meter or yard. We're starting with a 73 caliber barrel muzzle as an example. All pellets would hit a 15-inch target at 15 yards if that was true. When you actually do a real-world test, at 20 yards you can get 7, 9, or 19-inch patterns, depending on the gun, the cartridge company, the wadding system, everything we just talked about. And if you go for optimal, you'll get a 7-inch pattern at 20 yards, not a 20-inch pattern like you would expect. That's a 0.35-inch spread per yard instead of the 1. That means a 15-inch pattern at 40 yards with some cartridge and gun combos. Which means that the maximum effective range for double-aught buck, you would end up with exactly the pattern that would make all of the pellets count upon any attacker or anything you were hunting. Then we get little chestnuts like all 2 3/4 double-aught buckshot shells contain 9 pellets. Only if you don't roll crimp them, in which case you can stuff a lot more. The drag coefficient of a sphere is worse than a bullet, so you can't compare them, except when you can, because in short range, it's not relevant. Now, why am I doing this video? I was trying to look up this information and found very little data, so I'm presenting it in this video, because out of spite, because of my throat and sinuses that were damaged, most likely because of some dust that I was exposed to, and because I can't get any sleep, and because I'm feeling really, really sick, I'm doing this in spite of my health right now, because I'm frustrated with not being able to do videos about something I find at least useful to people who are looking for the information. This is a dumb subject to cover. Covered a lot. Done lots of videos on it. And it's because people asked these questions at one time and I eventually finished the video, so I've just done this one. One more drop in a sea full of stuff. Hopefully it's good stuff. Thanks for watching. Have a good day. Good luck.